Welcome to the quadratic formula, new work that we haven't done in previous years. So what are we going to do here? We're still solving a quadratic equation. And later on in these presentations, you're going to get excited about how we can use quadratic equations in a practical way, in something called modelling, mathematical modelling, where we use mathematics to describe a practical situation. So we know there are two basic ways of solving a quadratic equation from the last presentation. Those two. How boring that is. Over and over, repeating the same process. Is there a process that is identical each time you do it and could be formularised? Or could we develop a formula? Yes, here we are. Maths to the rescue, and that's the formula. Now, it doesn't look friendly, but it always works. It means you don't have to worry about factorising, and you don't have to worry about completing the square. You just put the numbers in the holes there. In other words, the B's and the A's and C's all refer back to the numbers in front of x squared, x, and the constant down the end. So if you have these numbers, you can stick them in their appropriate holes down here in the formula, and you will have the answer. Okay. So you can go straight to the formula and do that. All right, let's have a look now at why it all works, because you want to know the maths. You're a budding young mathematician. So here is the formula. Now, what do we usually do to solve this, right, if we had numbers there? Well, we would complete the square, wouldn't we? Because we don't know whether it factorises. So let's divide everything by a. So we get x squared plus b on ax plus c on a equals 0. Okay, so let's now complete the square. All right, we'll do it once in general, see what the pattern is that involves these coefficients, and then we'll have a formula. So let's go x squared plus b on ax. Now what do we have to do for our wish number? Divide this by 2, b on 2a, square it and add it on. Bring down the c on a and take off the b on 2a, all squared equals 0. Just remembering up here, when we divide both sides by a, 0 divided by a still remain as 0. Now this thing here should be, in algebra land, a perfect square. Is it? Yes, it's x plus b on 2a, all squared, but done in letters. Okay, let's see if we can keep going here. Now this is neg b squared on 4a squared equals 0. So we'll try and do something with that in a minute. So let's come down here. This is x plus b on 2a squared plus, now let's get it all over 4a squared. This is over a, so multiply that by 4a to get 4a squared. So we have to multiply the top by 4a to keep the meaning of the fraction the same. This is on 4a squared, so its top line stays as that. Now let's try and get the square by itself, like we had when there were just numbers. So that means moving these across the other side, so it become plus b squared, take 4ac on 4a squared. Alright, now what do? We want to take the square root, don't we? Remember, that's what we did when we were working with numbers. So it's plus b over 2a equals plus or minus the square root of b squared take 4ac over 4a squared. Right, let's keep going. So now, can we simplify the right-hand side? Well, let's take the root of the top line over the root of the bottom line, which is a perfect square. Root of 4a squared is just 2a. Well, it's coming along well. So now if we subtract neg b over 2a from both sides, we've got this. And I think it's magic. Maths is magic, mate. And we've got a formula. X is, they're both over 2a, so let's put them up like this. B squared take 4ac over 2a. And we've done it. Now this usually happens in maths. If you have a regular or standard procedure that you're using for all different types with all different numbers, you should be able to generalise it. Put in letters and trace through the problem what effect these letters, these coefficients have on the answer. So now what do we need? We only need the numbers A, B and C, and we can put them in this formula and find the two values of x that make this equation equal to 0. It's magic. Beautiful stuff. Please remember the maths. When you find yourself repeating a process over and over, you should be able to go through with just a general letter for each number and see where the numbers end up, if you like. Generalise the result. In general, what happens? Well, this is where A, C and B end up in the formula, in the perfect square formula. We've done it in general. All right, want to use it? I think it's good fun. You don't have to worry about factorising at all. You do have to be careful the way you stick the numbers in the formula so you don't make a mistake. Okay, here's the first one. So let's write it down. The number A is in front of x squared. B is -2, don't forget the negative, and C is -2. So putting it in the formula, I like students to write the formula first so that they can show they've carefully substituted into it. And you get this. Now you've got to be careful of these negatives floating around in here. So maybe do it on the calculator. We've got 2 plus or minus, this is plus 2, isn't it? Negative times a negative, plus or minus root 12 on 2. That comes into 2 parts. 2 plus 2 root 3 on 2. Let's write it down. They haven't shown this. Or to take 2 root 3 on 2. And you can cancel that. 1 plus root 3 on 2 or 1 take root 3 on 2. Again, you've got square roots in there because this one was actually not factorisable. Let's do another one. We can just go straight to the formula without trying to factorise if you like. Number in front of x squared is A. Number in front of x is B. Number down the end is C. Don't forget the -4. Then you carefully substitute those values in to the formula. Okay, so there it is, -3 plus or minus root of b squared, 9, take 4 by A by C, 32. That's root 41. So we can't do much simplifying here. It's -3 plus root 41 on 4 and -3 take root 41 on 4. Very nice. Okay. Do you think you like it? No more factorising, no more having to work out completion of the square. It's been done once and we have come up with this generalisation. Okay, come down and here's your chance to do some. Use the quadratic formula, so I'll write it here for you. Just remembering I would list the A, B and C values. Okay, so that you can then carefully stick them in the right holes in the formula. We need to do all parts here. Okay, it's getting easier though, isn't it? Okay, with these down here, if you're going to use the quadratic formula, you'll have to expand them all out using FOIL and collect all terms across to one side, because the formula only works when you've got the quadratic looking like this, not with two, one on either side. Okay, have a go, all parts here. And we'll show you solutions now. No, not the solutions, just the answers, isn't it? And notice how lots of square roots in here. Of course, you can use the formula even if the function is factorisable. Okay, if you don't like factorising, you could bail out and use the formula for those as well. Okay, let's keep going to some good parts coming up now. Here it is, this is what you wanted. Solve using technology. So here's one we know doesn't factorise. If you're allowed to use technology, there are two ways of doing it. Let's come over here. The first way is a graph way. So choose graph on the calculator and enter the graph, push execute, here it is. So what do we want? We want where it cuts the x-axis. So if you now here, I haven't shown the keypad, push shift and F5, you get, which is G-solve, you get the G-solve window, means graph solve. You can do any of these things and in fact go on the next window page and get that as well. What we need to do here is find the roots. This is really a misnomer because in a graph we call, when you put equal to naught, the solutions, it's not solution to an equation, it's the x-intercepts. We're solving a graph, and when we put the function equal to naught, we're really finding the x-intercepts. Roots belong to an equation, that is ax squared plus bx plus c equals naught. So it's really a slight technical misnomer there, because we're looking at a graph which has x-intercepts. An equation has roots. Okay, we're going to answer both of them mathematically with the same thing. That's the equation. And that's the graph of y equals ax squared plus bx plus c. And you have to put equal to naught for the x-intercepts anyway. So it's only technicality. So we're going to hit F1 to find the root, and then come down here. It'll pop on the one that's furthest to the left. And then if you use the button down here and hit that side, it'll come across and pop on the other one. Notice here that even if a graph, even if you've set the calculator up in math mode, or math selection for run mode in the setup, this comes out to be a decimal. It doesn't give you square root form here. It's not the exact answer, not the exact third form. Well, what's the other way of doing it? Come over here, you could choose equation mode, and when you hit execute there, you have these choices. Now, the quadratic equation is the simplest polynomial, poly meaning many numbers, many powers of the variable, because the quadratic's got x squared, x, and then no power, hasn't it? Here it is here. So that's the simplest of the polynomials. So if you hit execute in that window, it asks you for the degree. The degree is the highest power of the variable, which here is 2. Data exists in memory, but don't worry, we'll overwrite that. So if you hit 2, you come up with the window. Now it is mandatory, you must, compulsory, put the quadratic in this order. This is the A value, B value, C value, and it's taken for granted that you've got 0 on the right to use this. Okay, so if you enter those in, executing one after the other, and then hit execute. Okay, so here they are all entered, then hit execute, you come up with the 2 solutions. Please notice that here, if you've got the setup in math mode, it will show you the exact mathematical answer with a square root of 3 there. And then if you scroll down, it'll give you that one also in terms of root 3. Okay, do, which would be neg 1, take root 3. Alright, so that's got a little bit of an advantage. You can get the exact third answer there if they ask you for the exact answer. Whereas over here in graph mode, it will only give you the decimal there. Okay. Alright, are you ready to try checking your work with the calculator or with technology here? So come down and see if you can do some with technology. And here we are. I want you to do this both in graph mode and using Equa and check what the solutions look like. Okay, so all the screen clippings here have been from Hayes and Harris, and they're making an interesting comment here. This type of equation, you could simplify it and put equal to naught, and then use graph mode to find the x-intercepts, or Equa mode if you expand it all. Equa does require it all in terms of x squared term, x term, and a number. But you could also do this. In graph mode, plot the 2 functions, that's that one, and see where they intersect. Like this is what it's really saying up here, isn't it? When is one function equal to the other function? So go down here to graph mode, put in the first, put in the second, draw the graph, then go shift, we want to solve a graph. So we'll shift G-solve, graph solve, get these options, and this time we want this one. Where do they intersect? So if you hit F5, it'll pop on there and show you the first point of intersection. Again, in graph mode, it's in decimal form. Then if we hit this side of that button, as mentioned before, it will pop up to the other intersection point up the top there and give you the x and the y value of that. Alright, so that's an interesting one there. To solve that equation you need really only the x value, because you want to know the x value to make the two functions equal. Alright, you want to try playing with those two ideas with these graphs here. So there are two ways you can put two y's and graph them and find whether they're equal, or you can simplify that expression and put everything across on the left. Okay, and you can do something similar with all of them actually. So I want you to be ingenious and try again all parts with as many different ways of approaching it as you can think of with technology now. Alright, let's go down and look at the answers, and here they are here. Okay, all in decimal form, so they've used graph mode there. Have a look at EQUA, because it has got the advantage of giving you the surd or irrational exact form. Alright, well, we're underway. We've got a bit of a helping hand there with technology and with the formula. So we're going to develop this further, and there's some exciting stuff coming up. We're going to look at the practical use of this, not just graph drawing. Okay, back to our original origins of bridges and reflecting telescopes and all the useful things that you can do with a quadratic function. Anyway, I'll catch you then. Cheers for now.